Hi everyone, this is Partha, your SI leader for Chem HC from Professor Pirrung. And in this video, I'm going to be doing some review on acid bases because I know it's been a while since you guys have seen acid bases and it's a possibility that it might show up on this exam. All right. So this worksheet that I'm currently doing is labeled acid base and it's on Google Drive under week 2. Okay. And the problem we're going to be focusing on is number 5. Okay, so number 5, the direction mentions use curved arrows to show the flow of electrons for each acid-base reaction. Okay, so on top of that, I'm also going to ask you to determine which direction the equilibrium is favored. Or okay, so slash determine the direction of equilibrium. Okay, so the first one, you always write your bases typically have negative charge or excess of electrons, and for that reason, this ethoxide here, right? You can imagine this is the sodium ethoxide that I've been seeing a lot this quarter. This is going to be your base, okay? And bases, what they do is they go and grab acids, right? So you've been seeing that this entire quarter that they go and grab acids, okay? And specifically, they go and grab protons, right? And on this molecule, the proton is highlighted for you, right? So what happens when they grab proton, right? So hydrogen, as you guys know, has 1 proton and 1 electron, right? So if the negatively charged ethoxide is grabbing the proton, that means that it's leaving the electron, right? It's not grabbing the electron, it's only grabbing the proton. That means the electron that are left on that H right here and will go to the oxygen, okay? And that's why the oxygen becomes negative, right? 1 electron comes from the bond that was with hydrogen, right? The proton went away, electron was there. The other one was already on the oxygen, all right? And this gives you these two product. Now, how do you determine which side is favored, right? So my trick is look at the charged species, and wherever the charged species is the most stable, is it's the side the reaction is favored, right? So our charge species for these, both this reaction is this O minus and that O minus, right? So what do you guys think is the more stable O minus? So the more stable O minus is the one on the right, this one right here. And why is that? It's because that O minus has resonance that is stabilizing the negative charge, okay? Versus the O minus right here, it doesn't have any resonance, right? Because it doesn't have any resonance, that means that the O minus on the left is not stable. The O minus on the right is stable. Thus, this reaction is going to favor the direction where the negative charge is more stable, okay? How about the second one? Again, so again, your base is what it has the more electron, and your acid is what's lacking the electron, right? So I would say that the oxygen, the lone pair on the oxygen is the base, and the acid is this H3O plus. Okay, and this gives you the product on the right. So again, here we don't have negative charge, right? We have positive or neutral. So which side do you guys think is the most stable? So I would say where the positive charge is more stable, right? Right. I would say the positive charge here on the right is more stable, right? Because that positive charge could be delocalized by resonance, right? So you could get this thing, okay? So because of that, the reaction favors in the right direction, okay? How about the third one? Right. Again, this is your base because it carries the negative charge. This is your acid. Now ask yourself, which negative charge is more stable. So what's the difference between the negative charge on the left and negative charge on the right? Well, the negative charge on the left, right, doesn't really have anything stabilizing it because it's like an sp3 alkyl negative charge, right? Versus the negative charge on the right, you have an sp negative charge that is stabilized by the sp orbital, okay? Because the sp orbital is close, sp hybridized orbitals, the electrons are lying closest to the nucleus. So that nucleus, which is, as you guys may have known, nucleus is filled with positive charges. So that positive charge is stabilizing the negative charge, okay? So anytime a negative charge is in the proximity of an electron withdrawing group or positive things, then it stabilizes, okay? Because remember, opposites attracts, right? Opposite charges attract, and then the like charges they repel. Okay, so this side is more stable. All right. How about this one? The last one, right? Again. So you look at which minus charge is more stable. You have nitrogen and you have oxygen, right? Besides the fact that there are two different atoms, right? You could maybe compare atom effect, but in this case, resonance always wins out, right? This O minus on the right, it has a resonance. The N minus on the left does not have resonance. Because the O minus on the right has resonance, the equilibrium lies to the right, okay? So let's go ahead and continue that for 6, okay? So the first question on 6, OH versus SH. Which alcohol or thiol, which one is more stable? So for this one, right, you're looking at atom effect. Again, you always compare the conjugate bases, which conjugate base is more stable. But the trick is you guys should get used to just imagining the conjugate base in your head without having to draw it out, okay? So if you take away the H from the alcohol, it becomes O minus. If you take away the S, it becomes S minus, okay? So which one do you guys think is more stable? O minus or S minus? So this has to do with electronegativity, right? So which one is more electronegative, O minus or S minus? I'll say O minus, right? O minus is more electronegative, right? Because it's more electronegative, it likes having the negative charge more to itself. And because of that, it's more stable. And OH should be more acidic. Okay. How about this one? NH2 versus OH. Again, it's gonna be between N minus and O minus. Because O minus is more electronegative, it likes having the negative charge to itself more. And because of that, it will be more stable. And because of that, this alcohols are more acidic than amines. Okay. How about this is a problem you could see very well in the exam, right? A ketone versus diketone, as many of you may have already figured out, right? Electron withdrawing group, which is the carbonyl, it stabilizes negative charge as well. That's why the protons that are alpha-2 carbonyls are acidic. Typically, sp3 protons are not very acidic, right? But since it's alpha-2 carbonyl, it will be more acidic because it has the carbonyl that could withdraw electron when it's deprotonated. Okay? So you have 1 carbonyl versus 2 carbonyl. So the obvious is 2 carbonyl. All right? How about the one on the right? This molecule right here versus that. So for this one, right, again, it's probably resonance, right? This O minus could resonate twice as much as the O minus to the left. So this is more acidic, and so on and so forth. And this is a question you might very well see on the exam because these are the type of molecules you're dealing with right now. So which one is more acidic? Which carboxylic acid is more acidic? So to determine, right? So this is not, this is more, this effect is the electronegativity difference, right? It's not resonance because usually halides don't really donate electrons to do resonance, or they don't even accept it, but they withdraw electron through inductive effect. So what is a better electron withdrawer? Fluorine or chlorine? So again, as you guys know, fluorine is the most electronegative element in the periodic table, right? So because of it, it has a pull on this molecule. It has a pull that's going in this direction, right? More so than chlorine. So this molecule will be more acidic. Okay, so I will put the answer up to this worksheet, and please do try it yourself before looking at the answers. And this would be great practice for your exam that's coming up.